All right, class, welcome to week 8, lab 8. For this lab in particular, it's going to be very calculator heavy. So if you do not have it out already, go ahead and get your TI-83 because we're going to be using it in every way today. So for the very first one, we're going to talk about lines of best fit. Hopefully you have already gone over this in your 171 class. But if you have not, just pay close attention because I'm going to be going over a lot of how to use it, how to read it, and how to make predictions with it. So we have 7 students. They were asked to create a list of the most recent foods that they had eaten, and the students then looked up the amount of protein and fat in these foods, and the results are given in the table below. So we have a roast beef sandwich, we have fruit roll-up, garlic parmesan wings, grilled salmon, pepperoni pizza, hot fries, popcorn chicken, yada yada. Lots of information. All I need to know is I have a table. I have one list and I have another list. The first list is protein, the second list is fats. So it says, let's create a scatter plot of the data in our calculator. So I am going to and I'm going to walk you through how to make a scatter plot. So first thing that we need to know, all right, this guy is going to be list 1. This guy is list 2. So what you're going to do is you're going to go into your stat on your calculator, just like you've done before, and you're going to go over to stat edit, and we're going to edit list 1. So to edit list 1, I'm going to go ahead and clear mine out. I'm going to hit clear, enter, and that's going to clear out list 1, go up to list 2, hit clear, enter, and again, never hit delete. Never, ever, ever hit delete, only hit clear. Okay, so for list 1, I have 30, 0, 65, 22, 13, 2, and 60. All right, now I'm going to go over to the next one. I have 35, 1, 65, 11, 7, 8, 30. Okay, so I double check to make sure that they are even, because if they are not, it'll give me an error. So I double check all of my work, make sure I have everything in there nice and proper, because one tiny little mistake with my numbers here will absolutely affect every answer that I have from this point on, and it means that I'm going to get every single answer wrong. So always go back through, always double check to make sure that everything is lined up exactly the way that it should be. So notice in this week's lesson, I already have everything in there. So I have my list 1, I have my list 2. Now I'm going to follow the directions. I'm going to second quit to get out of it. I already did my edit list 1 and list 2. Now I'm going to hit y equals in my calculator. And I'm going to go up and I'm going to select plot 1. I'm going to hit enter. I want it to be nice and bold. Just to double check, I move my cursor down. And I notice it's bolded just the way it should be. All right, so I'm going to, just in case it's not bolded, you can go into second y equals stat plot, and we make sure that stat plot 1 is on. I notice that my very first thing that I have right there, it says it's on. So I'm good. So I hit plot 1, and I'm going to go to my graph. Oh, I can't read my graph. I can't see everything that I need on my graph. So what I'm going to do is I'm going to have to change my window. So of course I'm going to hit second window. I'm going to hit window. And I'm going to see what my X, which happens to be list 1, what the minimum should be. In this case, the smallest number I have is 0. So I'm going to put a 0 for the minimum. And the maximum, I'm going to look and see what my maximum number is. In this case, it's 65. But I want to make sure that I see everything that's on my graph. So I'm actually going to say 70, just so that I make sure it's all good. You can leave the scale as 1, or you can change that if you need to. And then I'm going to look for my Y minimums. Again, I'm going to say it's going to be 0 in this case. And again, I have a 65 there, so I'm also going to take it to 70 for my maximum. So now I'm going to go back to my graph, and I'm going to take a peek at it. Look! I have dots. I have dots exactly the way that this should look. All right, so it says we set up the window. We changed the window, the max and the min, so that we could see everything. We pressed graph. And now the next question they have is, do you think the amount of protein and fat in a food item are related to one another? Meaning, does it look like there is a trend happening in my scatter plot? And in this case, I'm actually not sure. The data isn't exactly close, so I can say that they are somewhat related. But there's no absolute conclusion that they are related. So, part B, it says if two variables are related, we say that they are correlated. Meaning there is a correlation between the two. All right, we complete the following sentence describing how these variables are related. It says, in general, as the number of grams of protein in a food increases, so do the number of grams of fat in that food item. Now it says, do you think this is a cause and effect relationship? Meaning, does one cause the other? Does protein cause fat? Well, no. We cannot conclusively say that these two things are correlated to each other. All right, so for part 2, it says, suppose that we want to predict the number of fat grams in an item based on its number of protein grams. We can do this by first finding a regression line. Okay, so we're going to be talking about regression line, linear regression model. We should already know how to do that. If you don't, I have the steps all in here. All right, but the easiest way I can tell you to do it is we're going to calculate it by going back to stat. We're going to go over to calculate, and we're going to go down to the number 4. We're going to hit enter. But I know I'm going to do some math with this equation that I'm going to find. So what I'm going to do is I'm going to make sure that the equation I have is programmed into my calculator. So I'm actually going to hit this vars button over here by the clear button. We go vars, go over to yvars, and we're going to select the very first number, y1. Now, hitting that means that it's going to be programmed into the y equals in my graph. So I'm going to hit enter, and it gives me my equation. All right, and it says, write the equation of the linear regression, round your coefficient to the nearest hundredth. Hundredth means that I'm going to have 2 decimal places. All right, so I have A is 0.757, which is going to round to 0.76x. My B is 1.65. Now, it says, what food would you like to eat right now? We're going to select a food, any food. In this case, I'm going to say, I want some salmon sushi. All right, so I'm going to look at salmon sushi. I've already looked up what the protein content is in salmon sushi, and it actually is 7.1 grams of protein in a serving size of sushi. And we're going to see if we can use this equation to help us calculate the fat that is going to be in this sushi. So what I'm going to do is I'm going to say 0.76. I'm going to plug in my 7.1 grams that I looked up plus 1.65. All right, so this is calculating it. So if I were to calculate this out, I'm going to get, oh no. Sorry guys. Oh, there it goes. Okay. So if I were to take and plug this in, 0.76 times 7.1 plus 1.65, I'm going to get 7.046. Okay, that's if I were to plug it in. But I'm going to take and I'm going to look for it in my linear regression equation, which, by the way, since I did that vars yvars, this is actually what it looks like. I have my scatter plot, and then I have my equation of my line. Now, I'm going to show you a slightly different way than what is given here, I'm going to show you a really fast way to get the answer using your table set. So I'm going to tell you to hit second window, right? So second, and it's not actually window. Anytime you hit the second button, you're actually going to look for the yellow button gives you yellow words. So we're going to do second table set. And we're actually looking for, well, in our case, is going to be 7.1. I'm going to hit enter. And then I'm going to hit second table, and I'm actually going to get my answer, which when I actually look at it is 294, which is 7.03. Right, so again, I'm going to walk you through exactly how I found my values. So it actually wants me to look at 25. So I'm going to do that too. So instead of actually following what they want me to do, it wants me to go to my graph. It wants me to hit trace. And then it wants me to get my cursor onto the line and hit the number 25. Right? That is one way to go about doing this. There is also another way. It's second table set. You plug in 25 and then you hit enter and go to the table, and it actually also gives you, so you did second table set. We actually put the number that we're looking for into table start. In this case, we put 25. And then we just hit second table, and it jumps right to it in our table. All right, so now we're going to take, and we're going to look at some more data. Oh, wait, I apologize. Note that there is more information in this section, but you are going to cover it in MAT 171, where you're going to talk correlation coefficients. Hopefully, if you did this, you have already turned your correlation coefficient on, which, by the way, if I hit second quit, your correlation coefficient, if you notice, is actually this little R. That's right here. That R is my correlation coefficient. It tells me how accurate my equation is. All right, so if you do not have R turned on, please let me know, and I will actually walk you through how to turn R on your calculator, but my assumption is Math 171 instructor did it. All right, so now we're going to hit second quit, and we're going to take a look at our polynomial regression examples, okay? So we're given some data, and in this case, we're given data about Starbucks. And in this case, it's giving me, what is it giving me? I believe it's the income. Yeah, their annual revenue. All right, so it's giving me the year, and it's giving me the billions of dollars that Starbucks has of our money. We're actually going to take, and we're going to find the equation of the linear regression line using this data, right? So notice we have our years, and then we have our revenue. So, of course, our years are going to be list 1, and our revenue in this case is going to be list 2. So again, I'm going to go to stat. I'm going to edit. I'm going to go up to list 1. I'm going to hit clear, enter. Go up to list 2, clear, enter. And I'm going to very carefully start putting my years in. 2012, 2011. Oops, see, I made a mistake. 2011. 10. 9, 8, 7, 6, 5, 4, 3, 2, 1, and I'm done. Now I need to very carefully go over to list 2 and start putting in my billions of dollars of revenue. So 13.29, 11.7, 10.7, 9.8, 10.4, 9.4, 7.8, 6.4, 5.3, 4.1, 3.3, Okay, so again, I double check, I make sure that it's even. And then I'm going to go and make sure that my years are accurate and that all of my data that I plugged in is correct. Because remember, just being 1 decimal point off means that I could have wrong answers. So I always go back, double check 9.8, 10.4, and make sure that my data is in here correctly. So my data is in. I'm going to hit second quit. I'm going to go stat. I'm going to calculate. I'm going to calculate my linear regression. But before I hit enter, I want to make sure that it's plugged in to my graph. So I'm going to go vars, yvars, enter, enter, and enter. So now this equation that I got, which we're going to go ahead, it says, find the linear regression, and we are going to write it down. So I'm going to do 2 decimal places. Even though if you do more decimal places, the more accurate your answer will be. So your instructor might like 2 decimal places. I have a personal preference of 4. Just because when I'm working with data, I'm really wanting the accuracy of my answers. So I would give 0.9633x minus 19.24. That's not a 0.24. 1924. I would put 8655. Okay, so I like accuracy. I do more decimal places. You might have an instructor that just says go ahead and do 2 decimal places. Okay, now we're going to use this to predict the Starbucks annual revenue. So it says, use your equation to predict Starbucks revenue for the year 2013. Now again, I could go back to my graph and I could try to find my line and readjust my window, or I could just hit second table set. And in this case, I plugged in years, so I'm going to put 2013 in, hit enter, and go straight to my table. This tells me that I have, in the year 2013, they have a revenue of 14.16. So we have 14.16. By the way, don't just give me 14.16 for an answer. If I'm having a word problem, you're more than likely going to give me 14.16 what? So we're going to put 14.16 billion with a B dollars in revenue. Okay. Now, the model gave us 14.16, but it actually wants us to look it up. So it says, did your model give you a fairly accurate prediction? So what we're going to do is we're going to go into the good old Google machines, and we're going to look it up. We're going to put in, let's see, I think I want to put in 2000, what do they want? 2013. We want the Starbucks revenue. And we're going to see. What do we get? Oh, come on. Well, it's taking its very sweet time. I apologize, guys. 2013 Starbucks revenue. There it is. Okay, so if I were to look, oh, look, there it is. Very first article, it says 2019, it had 2014, 13. I just saw it. Well, it was back there on my main Google page. It actually says in the year 2000, in this Forbes article, it says 2013, Starbucks saw 14.9 billion with a B in total revenue. So they actually had an actual of 14.9 billion. So slightly off, but extremely close.